Okay, in this video, we'll be looking at determining if a triangle exists. What this means is, in the previous video, we saw that we were given information without an illustration, meaning we were given angle measurements and the dimensions of sides. And we started to use the law of sines without a picture being drawn. So we need to determine if the situation even exists, meaning if it's a triangle, to even begin to use the law of sines. This is what I mean. Here, we were given nothing but measurements, no illustration to accompany it. And so we would typically jump to the conclusions of using the law of sines. Here, we were given an angle, the opposite side, and a second side. So we were given angle B, side A, and the side opposite, side B. So if this case, we actually have to consider, would this actually make a triangle? And so we would typically use law of sines, but before we use law of sines, we must consider if this situation is possible. So let's look at the situation. We were given angle B, we were given side A, and also the opposite side B. If we made this triangle here, and if I drew the actual height, notice side B. If side B is shorter than this height, we actually won't make a triangle. We end up with this figure. So, in order to determine if this figure actually makes a triangle, there's a comparison between B and the height that needs to be made. So let's put some actual numbers to it. So, the measure of angle B was 43 degrees. We've got side A is 9 inches. And if I drew side B only being 5 inches, it is evident from here that 5 inches, that won't make an actual triangle. So if I drew the 5 inches, I can see that that 5 inches is shorter than the height. So we maintain that if I make a comparison between the height and that opposite side, that would help us determine if in fact it is a triangle. So the height we drew is called actually the altitude, and it forms a perfect 90-degree angle with this bottom side. So if I just focus in on the triangle on the left, I've made a perfect right triangle. We have angle 43. The 9 is our adjacent side, and the h is the opposite. So we can use sine. So when we substitute the values in, solve for h, multiply 9 on both sides, we get 9 sine 43. When we substitute that into the calculator, 9 sine 43, it's already in. We get 6.137, etc. So that means the height is a little bit more than 6. And as you can see, 5 is less than 6. So that says we're still left with the triangle, that a figure that doesn't actually make the triangle. So we see that if we are able to compare the opposite side with the height, that's the information we'll use to determine if the triangle even exists. So what we need is a quick way to find h. Well, we were given an acute angle. We were also given the side opposite that acute angle, and we were given a second side. We found height by multiplying 9 times sine 43. 9 just happened to be the second side. 43 was the acute angle. So we have a generic formula for finding the height. Height is equal to the second side times the sine of the acute angle. And so to be a triangle, the opposite side has to be greater than the height. So the conclusion, if we were given an acute angle, the opposite side, and a second side. So this is a very specific case. If we were given the acute angle, opposite, and the second. In order for it to be a triangle, the opposite side has to be greater than the height. And the way we find the height is take the second side multiplied by the sine of the acute angle. So now let's look at not oblique, but obtuse triangles. Okay? In this obtuse triangle, we have our angle, we've got a side, and we have the opposite side. So same situation. Here it's quite evident that A has to be bigger than B. So if we put some actual numbers, 120 degrees, if B was 8 inches, it is evident that A has to be greater than 8. So, conclusion, if we've been given the obtuse angle and the opposite side and a second side, in order for it to be a triangle, the opposite side has to be greater than the second side. So we've looked at both situations in determining if a triangle exists. If you were given an angle, opposite side, and a second side.